Okay, so I am going to be talking about Windows Azure Storage. They leave me for last because I tend to be long-winded, so hopefully we can get this wrapped up in a reasonable amount of time. Windows Azure Storage, basically this is storage in the cloud. How many of you have been using Azure for a while now? Any, yeah? A few hands out there? Okay, so you're probably familiar with this, right? Because this is back to the core fundamentals of Azure when it first came out. This is storage in the cloud, right? It's got all the goodness that we've been talking about all morning long. It's scalable, it's durable, it's available anytime, anywhere, right? The standard type of cloud goodness. It also has the benefit that we only pay for what we use. So it's not like I have to go out and commit to buying a terabyte of storage. I can just go out and store things as I want, and this month I've got 100 megs, and next month I've got 200 megs, and my bill doubles, right? But it's still a really small bill. And when you look at it, go out and look at the pricing calculator. I was chatting with some friends yesterday, and it is incredibly cheap for how much it is to store stuff out there. So Azure Storage is one of the facets of Azure that has really taken off. It's also, as we've talked about in a couple of different areas so far, it is exposed by RESTful services, right? So whether I'm using the SDK or whether I'm calling the RESTful services directly, it's still using the RESTful services. That's still what underlies it. So it's available anywhere out on the internet. So again, we can go through, we can host our storage adjacent to where we're pulling, where our compute is hosted. So if I'm going out and creating a website, I can host my compute in the West US. If I need to distribute that, though, I have other options. So I can go ahead and Content Delivery Network enable that storage. Now the Content Delivery Network currently is being retooled a little bit, so you can't sign up for that, but there are 24 edge nodes that are out there. You can, again, distribute that content. It's very fast, very efficient, and locates that all around the globe. As we talked about, you can co-locate your storage with your compute, so we can use either affinity groups or just by naming the data center. There are two keys, right? When I need to access that storage, when you need to access that storage, you're going to ask me for a key that says, yes, I have permissions to do this. Those keys, there's two of them, and they're rotating. So again, the idea is that you can continually rotate through those keys and keep them fresh. And there's up to 100 terabytes per account. So it's really a lot of storage that's available to us. And one of the first questions that we as developers ask is, okay, that's fantastic, but how do I do that locally, right? How do I make sure this is going to work? How do I prototype? How do I work on my dev environment? Well, there's this, just as we looked at the compute emulator earlier that Michael showed us, there's also a storage emulator. It provides mock or fake storage that allows me to use queues, tables, and blob storage locally. It does use SQL Express or above, so you will need that. But again, it's very quick and easy. There are some differences to this, and one of the sort of recipes that we have seen as we've gone forward and as we as Catapult have embraced Azure as our development platform is that what we typically do is we start developing everything locally, right? I get on a new project, the first thing I do is I fire up Visual Studio, I start writing code, and I'm storing stuff into queues or blobs or whatever it is, right? And everything's happening locally. Well, one of the first things that I want to do as that solution starts to mature is push my storage out to the cloud, right? So I'm going to move that blob storage out. I'm going to move those queues that I'm using. I'm going to move those out, and I'm going to reference them locally, right? It's available anywhere, which includes my dev box. So that's a pretty easy task. The next thing that I will do is I will then, as my solution gets close to being deployed, I will deploy it to a test instance out there. Now, again, remember, it's one of those caveats, right? Pay as you go sounds fantastic. It also means, though, that you're paying the same amount for a staging environment as you are for a production environment, right? So I'm not going to want to deploy that until I'm getting close and I really need to test that. So again, multiple stages, right? Complete local dev, then I'm going to move my storage up to the cloud, and then I'm going to move everything up to the cloud. All right, so the storage client API, right? We've talked about these APIs as we go through. This is the part of the presentation, or all of our presentations this morning, that is going to be of great interest to some of you, and to some of you who Azure makes this so easy and you're just going to use the APIs. You're really not going to worry about that too much. But there is that RESTful API that's underneath, and on top of that, there are a bunch of different APIs, right? So there's the C# library, right? That's going to be handy to us if we're using Visual Studio, but there's also Python, Ruby, Perl. Thank goodness we finally got Erlang covered, right? There's a lot of different options that are out there. Security, right? This is the next question that I always get. Okay, I'm going to throw my stuff out there in the cloud. How are you going to guarantee that I have security, that I can secure that as I need to? And there's a couple of different things, right? We can secure at, first off, everything's over HTTPS. We can secure at an individual blob level. We can secure at a storage container level. We'll talk about storage containers in a minute, but essentially using, again, these sort of older analogies, this is talking about securing either an individual file or securing a folder. There are those two keys that we talk about, right? So if one of those is compromised, we can switch them out and then move on to regenerate that key and constantly have a fresh one ready to go. And then I can give very specific access using shared access signatures. We're going to come back to this, but essentially it allows me to say, you have access to edit this file from 5 p.m. to 7 p.m. today, right? And then after that, it's expired. So let's take a step back. What types of storage are available to me in Azure? Well, there's blobs, there's tables, and there's queues, right? Blob is, again, analogous to storing a file out on a file system. We've all done this. Tables are analogous, but we're going to talk about some asterisks and footnotes to using a relational database. And then we've got queues, which are basically a very simple first in, first out, right? Any of you who did the whole enterprise application integration and patterns and all that stuff a while back when that was really big, right? This is not that. We don't have tons of different patterns in how we do this. It's a very simple, very fast, very efficient queue that allows me to queue up work for different worker roles to pick up. So, starting with blob storage, number of different concepts we need to understand, right? First off, there's a storage account. That's associated with my account. Very simple. The next thing we've got is a container. So I'm going to create a container to hold those things. Again, fairly similar to what we know in folders. Under that, there are individual blobs. So I can create, upload each of the pictures of my kids, right? And those are each going to be individual blobs that are going to be out there. And then depending on the type of blob, you could have pages or blocks that underlie that. Now that's not something that most of us are going to need. We're not really going to get into that today. But do know if you're writing the next competitor to YouTube, you can go ahead and have blobs that are specifically targeted at streaming, or you can have blobs that are specifically targeted at random access. When I want to access one of those things, right? When I have a publicly available blob, I want to give that to you. We want to access that through a website. I'm going to get a URL, and that URL reflects the structure that we just talked about. So there is the account, right? That's going to be the first part of it, right? Noah test storage dot blah, 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 something like we looked at earlier. There's the container, so that's going to be in there. And then the individual blob name is going to be reflected at the very end, right? So this is going to look like Noah test storage dot blob dot core dot windows dot net slash mykidspics slash tesla dot jpeg, right? All that's going to be out there. From that web service that we talked about, there's plenty of operations that we can do. Most of these are really obvious, right? I can put a blob up there, I can get a blob back. Those are pretty simple things. I can delete, I can copy a blob. And then there's a couple that are a little, maybe not quite as straightforward, right? So I can take a snapshot of that blob. So I want to grab that thing so that I can hold on to it for a little bit. I can also lease a blob, right? I'm in charge of editing this thing. I'm going to say, I'm going to get a lease on this. This is mine for a little while, right? I'm holding on to this thing, and you can't edit it until I'm done and release that lease. I'm sorry? Yes, very similar to a lock. I can also associate blobs with metadata, right? This is great for content. In fact, one of the demo that I'm going to do is we're going to create a very simple HTML file and an image and put it out there. We'll look at that metadata, and you'll see that the content type is HTML, right? So that way, anything downstream knows what's coming and can prepare for it. You can do that either as part of the put blob when you initially load that up, or you can set that metadata later. So blobs are also accessed by name, right? And one of the things that people come along and ask is, okay, so I've got how do I do a more sophisticated hierarchy for storing my blobs than just account and container? Well, you can't, really, but you can approximate that by including special names, right? So in this example, what I can do is I can do container/myblobs/blob.jpg, and I can basically take that shortcut, right? So that slash in there, the name of this thing is myblobs/blob.jpg, right? That's the actual name. And again, those of us who are used to using file systems, which is all of us, that doesn't look right. But in Azure, that flies just fine. But then I can use that for my application, and it looks like that hierarchy, right? So all of the pictures of, I can do my kids /Kelvin/Tesla/ and each of those blobs are going to be /Tesla/Halloween/Kelvin/Halloween. And then it's obviously very easy for me as the application developer to parse that out, and I get Kelvin, Maxwell, and Tesla, right, as my 3 different containers, my 3 different folders that are available. So again, nice little shortcut there. Jumping back to blob containers for a minute, there's a special root container. There may be times when you need to use this, some special circumstances, and I'm going to go into that now. But a container can hold the set of blobs, right? Again, it's very analogous to a folder. You can set metadata on that container as well as on the individual blob. And then we're targeting, just so you know, when you look at these numbers, we're looking at targeting 60 megabits per second per blob. So that's pretty fast. Okay, so what we want to do is get my monitor working. 60 megabits per second per blob is what we're targeting for throughput. So it's pretty fast to be able to download or upload. All right, let's see.
Yeah, you just keep repeating the question. Oh, and you got it yourself now, huh?
Maybe.
You get it?
No. Yeah. Yes, per second per blob. Yep. So there's a lot of throughput there. Okay. So what I want to do is just go through a real quick. I want to look at the blob service, or the Windows Azure portal. We're going to create a container, and then we're going to try and upload some content to it, and maybe look at some permissions and metadata really quick. All right, so managed.windowsazure.com. Let me get signed in here. All right.
So you're going to show us how to programmatically access the blob?
You're actually going to programmatically access the blobs.
Noah, could you repeat that question for our online
Yes,
audience?
I'm sorry, thank you. The question was, am I going to show how to programmatically access the blobs? And the answer is no, not right now. I just want to show the portal and uploading, downloading blobs and how we integrate that into Visual Studio. As part of your lab, you're going to be accessing and manipulating blobs out in storage. And you're going to do 2 labs that do that. The first lab is just going to be basically storing those out there. The second lab you're going to be doing, it's a similar lab, we're just going to add shared access signatures so that you can grab permissions, much more fine-grained permissions on those blobs and containers. Okay? All right, so if I come into storage, I've got a couple of these funny named storage containers. Those are associated very specifically with the virtual machines that I've got running in this account. So what I want to do is create a new storage container. We'll do a quick create and make sure nobody's taken my Noah Dallas test. That looks still available. We'll create that storage account. This should just take a second to create. All right. Okay, or maybe a couple of seconds. I am going to see. All right, so while that's still going, I am going to, oh look, I still got my one from yesterday. Let's create a new one though. I'm going to create a very quick web page, right? So HTML, let's add a body, let's add a note. How about I spell that right? Add a note. Hello Dallas, and we'll add an image. source equals, we know it'll be broken for a minute. Oops. 1 second. Just turn the power off. Turn it back on. There we go. And we'll wrap that up. And HTML. Okay, so this is a typical, standard HTML file. We'll save this guy onto my desktop, and then I should be able to come into here. And you know what? We won't even worry about that now. I'm a little rushed on time. Okay, so what I want to do now is fire up Visual Studio again, and on my Server Explorer, you see there's this Windows Azure node. This is currently connected to my account. And under Storage, I'll probably have to, oh, it's refreshing already. Oh, it's going to ask me to log in. There we go. So now we see under Storage, I've got my development. Here's my Noah Dallas test. I've got blobs, queues, and tables, and I don't have anything out there because this was taking a little long, and I need to create my storage container. So we can come into containers. I'm going to create a container, and let's create one container called HTML, and we'll make that one public. And I want to create another container called images, and we'll make that one also public now. I'm sorry? No, I created the storage account. So the question is, didn't I have another container before? And I created the storage account, and while it was provisioning that account, then I got distracted and went off and started doing some other stuff. So now we're going to come back and create those containers that we talked about earlier. Okay. I'm sorry?
Because it's charged differently, you have to have a different account?
So the question is, because it's charged differently, do I have to have a different account? And the answer is no, these are under the same account. I'm just creating these containers, right? So I can have as many containers. It's similar to having folders on a drive. And all I'm doing right now is creating a folder to store my HTML and a folder to store my images. Does that make sense? Okay. All right. So now I've got my two storage containers out there. This is in Visual Studio, local on my PC. And what I wanted to show was the integration with Windows Azure Storage. So it used to be that we had to use a bunch of different tools to upload or download files. As Visual Studio has embraced Azure, I can now go out and upload and download files from within Visual Studio. It's very nice. So this is my monitor that decided to not work again. Back on. Go. Yes, no, maybe. There we go. Got it? All right, and yep, menu once more. Okay. So from within here, I want to my HTML, I'm going to go through and upload a file. I had that on my desktop, and don't remember what I called it. My something, I think. Oh, I misnamed it. All right, so I want to go ahead and save this as mypage2.html. Okay, now I'm going to upload that blob. That should be in here. Let's try that again. There we go. There's my page. I'm going to upload that. It's just going to take a second to go. While that's going, I'm also going to come into my images. And I'm going to upload a blob here. We'll just pick a picture. Here we go. Pick a picture, open that, and upload that thing. Now, this is a picture, and you can see that it set that content type for the metadata automatically. Now, I've also got the URL out here, so we can see that. I can see the similar information reflected in here. So if I come into my images, I now see that thing. I can copy that, paste it into a new tab, and we should be able to see that image that came down. It may be upside down, but it's there, right? So that's the same image that we just uploaded. Now, I should also be able to come into here. Let's go back to my HTML. Whoops, a little further than I wanted to go. HTML, and I should be able to copy that, and we should see this. Probably will have a broken image, which it does, but we see the Hello Dallas, right? So I've now uploaded my HTML and my images. Let's go fix everything up. Right, so let's go back. Let me get this URL. We'll copy that. Come into here. Put that as our source. Save it. And then I'm going to come back into Visual Studio and go into here, and we're going to re-upload that file. It's going to whine at me that it already exists, and do I want to replace it? And I'm going to say yes. Open. Okay. All right, so that is now updated. And I should be able to come in here. Oops, let me go get that URL again. Copy that. Paste. There we go. And now we have this fantastically sophisticated web page that I have just stored. Yes, I had a question. Yeah, it was the upload that did that. Let's go out.
Can we repeat that question again?
Yep.
Sorry.
Sorry. So the question was on the content type, what was it that assigned that? And it was the upload process that did that. But let's go out and look at the metadata for that. So I've got my HTML, and I can come in here. Oh, bugger. Sorry, it's just really hard to drive when I'm looking over my shoulder. 1 second. See, and Eric has no confidence in me. There we go. See, it's just that you have to be within 6 feet of it. Okay, so I can come in here and edit this guy, and it's going to. You can see it says it's loading the properties for that. So we can see the blob type is a block blob, the content type, the metadata. You know, so this is all of those blob properties that we've got. I think, let's go back and look at my images. So I can do the same thing here and edit that. And here we see the content type is already populated for us. So I would actually have to go out and populate that for the HTML. So the question is, would that be empty if I use the RESTful API to post something? And the answer is it depends on how I do that. So I've got two options. Either I can set it after the fact, or I can set it as I upload that. And so there is a call in the REST API that allows me to upload a blob and set the content type or the various metadata tags as I go. Okay? All right, one more thing real quick. I can come in here and, good, this is my image. So actually, let's go back. I want to set in here. Oh, I want to set in here. Let me click here. Edit. Now I'm editing my container at this point. And just for giggles, I want to turn this private and click Save. Okay, so that is now completed. And if I refresh my page here, we should see again I go back to a broken image because that's now a private container and I don't have permission to access that. Does that make sense? We're going to get into some more of the details about shared access signatures and how we do this at a little more fine-grained level. I'm going to get into those in just a minute, and then we're going to get into that as part of the labs that we cover today. All right, any questions before we move on? Okay. Back to here. Let's see, slideshow. Okay, so we did that. Now, I mentioned earlier there are two types of blobs. There's block blobs and there are page blobs. If I'm writing the next YouTube, I'm going to use a block blob. That's targeted at streaming workloads. I can basically go through and get a sequence of blocks, and those are going to be queued up to stream down to me very quickly. There's a smaller limit on this one, so it's only 200 gigabytes per block blob, but there's obviously ways that we as developers can string those together. So if I need to upload 350 megs of video, or 350 megs of video or gigs of video, I can do that, right? It's also got optimistic concurrency, so it's not quite as sophisticated on how we can control editing or access to that. Page blobs, they're targeted at read-write applications, so if I'm writing the next version of SQL Server, I'm going to be looking at doing page blobs. Each blob consists of an array of pages. You can edit or release those different pages. Now, here's that magic 1 terabyte number again, right? This is why when we talked about drives earlier, the limit was 1 terabyte. It's because they're using page blobs under the hood. We do also have more sophisticated control over how we can control leasing and concurrency. All right, shared access signatures. I mentioned these a couple of times already. Again, this is how I can give very, very fine-grained access to the blobs that I have stored out there in Azure, right? So again, I can say you have permissions to view the files in this container from 5 to 7 o'clock this evening, right? That's a very fine-grained thing. That's much more fine-grained even than we can usually do on a file system. I can revoke those, I can send them out, and there's 2 broad approaches to do that, right? One is ad hoc based and one is policy based, right? So I can say this is a broad policy, you always have access to this container, or I can say, you know, you very specifically have access to this file, this blob. So we can basically go through and create those short time-limited signatures, right? The shared access signatures that allow us to go through and control those permissions, right? So if I'm writing an application where I am allowing you to upload your files, I can go and give you a URL that says, here's a container, you have permissions to upload this for the next 5 minutes. If it's going to take longer than that, you come back and ask again, I'll give you another one, but I'm not giving you carte blanche to write out there. There's multiple pieces of these signatures that you need to look at. So the first one that we're pointing at here is the type that we're looking at. So in this case, the C indicates that it's a container, not a specific blob. There's a start time and an end time. And then we can also look at the permissions. In this case, the W that we've got says that we're able to write to that. And then, of course, there's that signature, right? That's the real meat of this. That's what allows me to not just go through and hack this stuff together, right? I need that signature. That's the hash of all this. Okay. So again, policy-based signatures are fairly similar, right? This is where I can grant you ongoing permission to upload to a container. Again, we've got start time, expiry time, permissions that you have for that container. You can take that URL, then you can upload the files, you can retrieve a specific file, whatever. All right, questions on blobs before we move on?
So why is HTTPS more highly recommended over HTTP?
So the question is, why is I gotcha. The question is, why is HTTPS recommended over HTTP? And it's because it's secured, right? So because we are passing the signatures back and forth by URL, we don't want to make those necessarily publicly available. Okay. All right. So table storage. Again, similar kinds of concepts, right? We're storing reasonably tabular data out there in Azure. How do we do that? We've got an account. We've got individual tables, and then on those we've got entities. Now those of you who are paying attention, and I haven't put to sleep yet, will see that over on the right-hand side, some of those are looking a little different, right? We've got name, email address, name, photo, right? These are different entities. So while I need to jump up and down, and as my grandmother would have said, stand on my head and spit nails, and tell you that this is not a relational table, right? This is not what we're used to in SQL Server. This is a little more closely akin to the NoSQL movement that people were doing a little while ago, right, about how we store data with key value pairs, right? This is basically that on steroids, right? So there's no relational integrity. I can't create a foreign key out there. A lot of the things that we're used to in SQL Server, I can't do in this tabular storage. That's why we have SQL Azure Storage, right? That's why we can run SQL Server on a VM in Azure. This is a different beast. What I'm doing is I essentially create a table, and into that table I can put entities, and those entities I can put in whatever I want. So I can do common operations, I can insert, I can update, I can select, that sort of stuff. But as I look out there, I can have, again, different types of data like we saw in that previous example. So I can have dates. So say I'm trying to do customers, right? I throw out an entity that says this is Noah, right? His name is Noah. His birthday is August 22nd, right? I can then go throw another entity for Michael and say, okay, this is Michael West, and his name is Michael West, and his birthday is yesterday, right? The string of yesterday, right? And I can put that out there, and the table is going to happily do that. You try it in SQL Server is not going to be happy with you. But that is supported out here, which means that you as an application developer need to understand the data that's going in as well as the data that's coming out of these tables, right? It may not be what you expect it to be, especially if you have multiple applications that are reading and writing from these tables. So that's this big point here at the bottom, right? There's no fixed schema. You can have up to 255 properties for each entity. So I can store my name, address, birthday, blah, 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 out to 255. There are a couple, though, that are required of you. So you have to have a partition key and a row key, right? Again, this is sort of similar to primary keys. And you have to have a timestamp out there for when that thing was touched. Again, jump up and down, no fixed schema, no relational data. It's not a SQL Server relational table. Okay. All right. So querying these things is fairly easy, right? It's all by URL, REST URL. You're tired of hearing me say this by now, right? I can add that filter that says last name equals West, and I'm going to get Mike's record back. Okay. I'm sorry?
Almost like searching your local drive.
The statement was it's almost like searching a local drive, and yes, it is.
What was the question again?
The question is, it's almost like searching a local drive, right? Where in Windows Explorer you can go out there and put something in, and it's going to do that search. Similar concept, yes. Okay, so what is this partition key that they're going to make us have? All right, anybody familiar with sharding databases? A couple people? Okay, so that's how, in Azure, this became a much more popular conversation back when SQL Azure was limited to much smaller spaces, right? And I had to say, oh, I've got more than the amount of storage that Azure supports, so how am I going to break up those databases? Well, now I got to start thinking about it. I've got a customer table. It needs to span multiple databases. I'm going to put these states in this database and those states in that database, and then my application has to know to go out and say, okay, go query both of them, go insert into both of them appropriately, right? The partition key is very similar to that, right? It's going to control what partition that data goes into. And this is important for table scalability because that scalability is tied to the partition. Okay, so they're going to target about, again, 500 transactions per second per partition, right? So if I want to fully embrace the transactions, the speed, the bandwidth that I can use, I need to break that up into multiple partitions. So an example of that, right? I've got a sporting goods store. I'm storing all of my products out there. What's a good key? Well, in this case, we may decide that a good key is what category that is, right? What department I'm going in. So if it's a bike, I'm going to put it in the bike partition. If it's looks like canoes, I can't imagine they'd have that many canoes, it'll go in the canoe partition, right? It's just that key. And it's something where you have to understand your data up front a little bit. Heard tell, I haven't actually seen this, but I've heard tell of people who tried to use something like a timestamp as a partition. Probably not such a good idea, right? Because one, it's always changing, so whenever you touch that, it's going to go into a new row. And two, you're going to get a new one for like every second or minute or hour or day or whatever it is that you're using, right? So there may be cases where you want to do that. Like if you want to break up orders in a high transaction volume system by day, that may make sense. But you probably want to think about it before you do something like that. So again, we've got multiple partitions that are associated with this. Okay. And again, you can break those up, right? So they can go across multiple servers, right? In this case, I've got bikes and canoes that are going out here. I've got everything else that's going into this other server. Yes, so the partition key...
Thank you.
So the question is, are we talking about physical storage? And the answer is yes. We are talking about physical storage here with a partition key. So if I bring up the super duper cycle and I decide that that's no longer a bike, that's a exercise bike which goes somewhere else, then that's going to physically move that row from one partition to another. Okay?
And just a note, so just so we can stay on time, we'll just ask you all to hold your questions to the end.
Okay.
We'll be able to get them then. Thank you.
And I probably need to speed up a little too.
Okay.
Okay. Last piece I want to talk about is queues. These are, again, very simple, first in, first out queues. Nothing fancy. This is not enterprise application integration that we were all talking about a while ago. The benefit, though, is that it allows us to make really tightly integrated but loosely coupled applications. So, I'm a consultant. I go into a lot of different clients, and there are a lot of them that have been developing things over the years, right? And it used to be we were doing things by API calls, and then we started doing things by XML, and now we're doing things by REST. And everything gets so tightly coupled that I can't go through and change this piece without having to touch a bunch of different things, right? So queues are a way that we can avoid that. I can say, rather than doing this, in the middle, I'm going to create this queue, and when this system needs something, it goes and throws something in the queue. This system goes, pulls it off, does something, and throws it back. And that way, we have just this one point of integration. It's very easy, very fast, and it really allows us to scale out those applications. In some other presentations we actually talk a lot about cloud thinking and about how these different things work. One application that we have seen for this, right, if we look at some of the disruptive technologies that are out there right now, right, one is the cloud, right? That's why you're all here, because things are changing. Another big one is mobile applications, right? So we're all looking at how we do mobile applications. How do I take this app that was a website and put it on a phone, that sort of stuff. When you throw both of those into play, it means that you don't necessarily understand your usage patterns anymore. So if I take my CRM application and I'm now making a mobile application version of it, I don't understand how people are going to use my old one. Are they going to use my new application instead of my old application? Are they going to use it in addition to? Are they going to use it in replacement? I just don't understand that going into it. So what I can do is I can throw a queue in the middle there and protect my on-premise application, right? My existing CRM application that has to continue working. I can protect that with a queue, right? And it gives me that additional knob so that when my mobile application wants to go out and retrieve data about Michael as a customer, right? It throws a message on the queue that says, give me information about Michael, right? And then I can throw something back on that queue that says, oh, here's your information about Michael. And it gives me that additional knob to turn where I can protect my on-premise application. Yes, a buffer, precisely. So what is a queue? Again, queues are very simple. First in, first out. Some restrictions on the names, but nothing big there. They can hold an unlimited number of messages. The messages must be serializable as XML, but that doesn't mean that you can't embed data in the XML, right? The first time I said they must be serialized as XML, people go, I've got binary data, right? You can still throw that in an XML message. They're limited to 64K in size. You don't want to put entire documents in there. And the common pattern is the work ticket, right? So as we go through, we've got a couple of producers, we've got a couple of consumers. My producers, as they work, are going to chunk things, oops, went too fast, are going to chunk messages onto that queue. My consumers are going to pull messages off. Messages go onto the bottom of the queue, they get pulled off the top. So what does that look like? Let's say I've got a web role that's out there and a queue. That web role receives a request, it calls put message, it dumps that message onto the queue, and then it can receive, obviously put multiple ones on there. In this case, I've got a couple of worker roles that are pulling that data off. The first worker role goes out there, says, hey, give me something to do, I'm bored, right? It gets that message, it processes it, and pushes it back onto the queue, and then it has to, take a step back. It pulls that message off, it processes it, and as at the time it pulls that off, that message, the queue marks it as somebody's looking at this one, I'm not going to give this one out again. Then that worker then has to go back and say, yep, I'm done with that one. And then the queue at that point will remove it. Let's say we have the second worker role, it goes out and grabs message 2, something bad happens. We don't know what it is, there could be a crash in the code, processing could take too long, not sure. It eventually times out. After that timeout, worker role 1 can go back and get that message, right? They say, I'm bored again, give me something to do. Because that timed out, it's going to get message 2, it's going to process it, and return it to the queue, right? It's going to go about its normal business. However, when worker role 2 gets done, it recovers from whatever went south. It's going to go and say, okay, I'm done now, but that message has already been processed off the queue, and the queue is going to go, you're done. Okay? So that's how we're going to control this. That's how we get the fault recovery. I will come back to your question afterwards, okay? That's how we're going to get that fault recovery, make sure things are happening. However, that means you as a developer need to understand that, right? That I'm not going to commit something until after or in coordination with pulling it off the queue and then giving it back that responded message to make sure it doesn't get processed twice or dropped. Okay, that's what I had to talk about. I think we're going to end the recordings now.